Hi and welcome to Polynomials Day 6, and today we're going to continue with our dividing. So we're going to divide by x minus a and x plus a. In this case, this is perfect types of problems for synthetic division, so I'm going to go through and do these with synthetic division because it will go quicker. I don't care at this point what method you're using for your division, just pick a method and stick with it. So for this first one here, find the following quotients and write the quotient in standard form. Well, if I'm going to do synthetic division, I have to put a 3 on the outside, a 1. I don't have a 0, x squared, or an x in there, sorry, so I need to put a 0 in for it, and then negative 9. Bring down the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. And my remainder is 0. So that means my answer is x plus 3. Next one. Again, since it's x minus 3, I'm going to put a 3 on the outside. I have 1x cubed, 0x squared, 0x, negative 27. Bring the 1 down. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 0 plus 9 is 9. 3 times 9 is 27. Zero's out. So my answer is x squared plus 3x plus 9. Try that again. I have this one spot that doesn't like to write. Hang on. Plus 3. All right. And then the next one, again, we're still dividing by x minus 3, and it's 1x to the 4th, 0x cubed, 0x squared, 0x, and then negative 81. Bring down the 1. 3 times 1 is 3. 3 plus 0 is 3. 3 times 3 is 9. 0 plus 9 is 9. 3 times 9 is 27. 0 plus 27 is 27. 3 times 27 is 81. Therefore, it's 0. So my answer is x squared plus 3, oh sorry, x to the 4th, sorry, plus 3x cubed plus 9x squared plus 27. So when we did this, there was a pattern with the answers. If you look at all the answers, everything is a power of 3. And our exponents are always a descending power starting at, let's see here. I'm sorry, I messed up writing this answer. My bad. X to the 3rd plus 3x squared plus 9x plus 27. Yikes. My powers are descending and they're all 1 less than what I had there. So what I'm talking about is my coefficients would be 3 to the 0, 3 to the 1st, 3 to the 2nd, 3 to the 3rd. Okay? Because anything to the 0 power is 1, 3 to the 1st power is 3, 3 to the 2nd power is 9, 3 to the 3rd power is 27. So if I were to do x to the 5th minus 243, I could easily figure out the answer. I also want you to notice that the powers are here descending. So where we have x to the first, the 1, x cubed, so we have x cubed, then I have x squared, then I have x, and then to finish off, we would actually have x to the 0 power, because anything to the 0 power is 1. So when I combine those, I get my answer. So use patterns to predict each quotient. Explain how you arrived at your prediction, and then test it by applying the reverse tabular method or long division. Well, we're just actually going to use the patterns to predict. This is all we're going to do. Just this part. So if I have x squared minus 144 divided by x minus 12, this should be, my powers have to be descending, x, and then you can see I'm dividing by 12, so it'll be x plus 12, and that's because 12 squared equals 144, and we just kind of divided out. So my next one, x cubed minus 8 divided by x minus 2. Okay, this would be, this would actually be a perfect cubes problem because x cubed is a perfect cube and 8 is a perfect cube. And I'm dividing by x minus 2. So we'd have, using what we did on the last page, 2 to the 0, 2 to the first, 2 to the second. So when I write out what my exponents would be, it would be x squared, x, and x to the 0. So my actual answer is going to be 2 to the 0 is 1, x squared, so it's just x squared plus 2x plus 2 squared is 4, x to the 0 is 1, so it's just plus 4. X cubed minus 125 divided by x minus 5. Again, these are perfect cubes. So I would have 5 to the 0, 5 to the first, 5 to the second, and my exponents would actually, or sorry, my variables would actually be the same as the problem above. So my answer would be x squared plus 5x plus 25. X to the 6th minus 1 over x minus 1. We're dividing by 1, so my coefficients are just going to be 1. And this is going to follow the same pattern. I'm just going to decrease by 1 power, so it's x to the 5th plus x to the 4th plus x to the 3rd plus x to the 2nd plus x plus 1. And the reason I don't have to worry about my coefficients because I would have 1 to the 0, 1 to the 1st, 1 to the 2nd, 1 to the 3rd, 1 to the 4th, and 1 to any power is just 1. So that's why I didn't really have to worry about those. All right, going on to the next page. So we were applying numbers. Now we're going to try to find like a general form. What is the quotient? And it says use the reverse tabular or the long division method. So I will do reverse tabular here. This is x, this is minus a. This would be x squared. This would be 0 x a, and then, or ax, and this would be a squared, negative a squared. So this has to be negative a squared, this has to be x squared. So what do I multiply x by to get x squared? It's x, so x times negative a is negative x a, and I need that to be 0, so that means this has to be positive x a, and I have to multiply x by a, so I just get x plus a for my answer. Alright, so here we need to find the pattern. Let's do reverse tabular here. So this is x minus a. This would be a negative a cubed. This would be x cubed. And then we have to figure out like what goes around the outside edges. Well, as I was showing you before, we'd have our exponents and our variables being descending, and then our exponents with our powers being ascending. For like the constant in this case, it would be a. So that would mean this is 0x squared a on this diagonal, and then this diagonal here would be 0x a squared. So that means this box has to be x cubed, this box has to be negative a cubed. And what do I multiply x by to get x cubed? Well, x squared. So I multiply x squared by negative a, I get negative x squared a. And I need that to be 0, so that means this has to be x squared a. So what do I have to multiply x by to get x squared a? Well, I multiply it by xa. And when I multiply here, I'll have x negative xa squared. And I need that to be 0, so this has to be positive xa squared. And what do I have to multiply x by to get xx squared? It's a squared. So my answer is x squared plus, typically we put the coefficient in front like this, because a would probably, or a constant, yeah, the coefficient would be like a constant number that we had there, plus a squared. So I don't actually have to do out the division if I follow the pattern of descending powers and ascending powers. So my x's, because they're first, would be descending powers. And the a, because it's second, would be ascending powers. So, oops, sorry. That being said, I can apply this for this problem. I'm going to start with 1 less than x to the fourth, so it'd be x cubed, and then there would be a to the 0 plus x squared, and then an a to the first plus x to the first, and then a to the second plus x to the 0, a to the third. So you can see my x's powers are descending and my a's powers are ascending. And when you clean that all up, it's just x cubed plus ax squared plus a squared x plus a cubed. And that would be our final answer. So what I want you to do is on the next page over here, predict without performing division whether or not the divisor will divide into the dividend without a remainder for the following problems. If so, find the quotient and then check your answers. So there's a couple that I want you to look at. Just I'll just have you do A and B. Just try those two and see if they work. And if not, that's fine. But if you look over here on the next page, if you're struggling with that, if you look in your packet, oh, where'd it go? There you go. Look on that on the next page of your packet, because I had adjusted some of this stuff. Based on the work in the lesson, this year we conclude the following statements that are true for all real values of x and a. This is going to help you with factoring a perfect cube. All right, well, that's it for tonight.